Welcome to Homework Answers. We're going through the textbook C++ Programs to Accompany Programming Logic and Design, 8th edition by Joanne Smith. And in this video we're covering Lab 4-2. And as always, make sure you correct the changes I've done to the solution. It's very minor stuff, so if you have the book and the data files, you'll know what I'm talking about, and it'll be really, really easy to change. But what we're trying to find with this problem is we've got three variables, three numbers, and we need to have those output as, well, we just need two outputs basically. We need it to determine what the largest value is and what the smallest value is. So the lowest number and the highest number. But we have three of these numbers here. It's very tempting to have in our if statements, if you look at our variables here, it's very tempting to say like, if x is less than, and then put a number there and determine it that way. But if you do that, what if these change and then x is no longer larger or smaller than whatever number you put in there, then you have to change all this code too. So the best approach is just to compare each variable, and it is kind of like stretching your mind. This kind of really, you're going to work your brain muscle there and might have some mind melting going on, but it's not too difficult. If you just look this over and sort of try to understand what's going on, it's split into two areas basically. We already know we need to output largest and smallest number, so we've got two variables for that. We don't need to output the middle number, so there's no variable for that. But we do know we have three numbers, so I've just put three variables here, x, y, and z, and they're each assigned to a number. They're initialized. One's negative 48, this one's 56, and this one's 88. So we have three numbers here. What we're going to do to make this, I guess, easy is we're going to compare two of them to start. And so you go, if x is less than y, then obviously x would be smallest and y would be the largest. Else, basically saying otherwise, if that's not the case, then x would be the largest and y would be the smallest. And then you have to, after that's done, that's the first part. Then after we do that, now we can incorporate z in there. And we're going to test z for both ends, the highest and the smallest. So we say, now that we have determined which one of these two, x and y, is the largest and which one is the smallest, now we're going to compare it to z. And we're going to say if z is greater than the largest, because up here we know what the largest is, then now z is going to be the largest, and everything else will fall into place. Or otherwise, if z, and I'm pretty sure we do have to test it for the smallest too, so if z is less than the smallest, then z is going to be equal to the smallest, and everything else should fall into place, because these two up here, x and y, are already determined where they fall in the order. And so it's not too difficult when you look at it here, but to kind of get to that point where you're thinking logically there and how would you set this up, getting there is a little bit tough, but now that you see it here, it's not too difficult to really grasp the concept. And then your output, the largest value is largest and the smallest value is smallest. So with this setup here, we can change these values at any point in time and it's still going to give us an accurate result. And I'll go ahead and run it so we can see. And that is correct. So let's say if I change this up here to 70. Now it should be z would be the largest and y would be the smallest. So let's go ahead and run that again. And it's right. So with that kind of setup, we've got a pretty well working program here. And I think that's about it for this problem. So thanks for watching, and I'll see you in the next lab.